Thanks for having me here. Appreciate it. Thank you, everyone, for joining us. I know we're a little late before lunch, so we'll cruise into that. My name is Rob Witoff. I'm a director at Coinbase. Today, I'm going to be talking about consensus engineering or consensus infrastructure. Okay, and to define a little bit about what this is focused on, we believe this is an architectural pattern, something we're investing really heavily in at Coinbase today. And we think this helps not improve or take an incremental step to address some of the problems we see in security today, but this takes a giant leap forward. We believe this is a core part of the future of Coinbase's stack, and we think this could be a core part of everyone's stack. Okay. For those of you that haven't seen Coinbase before, and can I get a quick show of hands? Does anyone have a Coinbase account? Awesome, this is great. So maybe a third of the room. We'll show you a little bit about how we're keeping some of your deposits safe. And when we talk about security at Coinbase, this is a snapshot of our website. A lot of people say something about security on your homepage. You say it's core to our business, we focus on it, it's paramount. But I don't think a lot of people take it as seriously as some of us do in finance. So this is truly core to everything we do at Coinbase. We talk about security and think of everyone at our company as a security engineer or a security leader. Okay? But the truth about security and technology today is that we're getting hit pretty hard. And honestly, I don't think we're doing a very good job as a large group of technologists that are being faced with some pretty heavy security challenges today. And now, could I get a quick show of hands from maybe everyone in this column in the room? Right? So in the past year, about 10% of our countries had their identity stolen. I personally have had my identity stolen 3 times in the last year. Right? We haven't been doing a very good job about securing some of our core assets. Okay? If I could have maybe everyone in this whole block of the room raise their hand. Okay? So we've had about a third of the country, for any of you that are into healthcare or have been to a doctor, but a third of our country has had your health records compromised or maliciously taken from your records. And we've seen some other really nasty things happening over the last couple of years. Things like the Ashley Madison database breach, which is not just information being leaked, this is real blackmail and extortion content. Okay? Or even seeing larger nation states getting into this game of publicly exfiltrating a lot of our information. We see a lot of this as well in our industry. In the cryptocurrency industry, you've probably seen quite a few mentions in the news, hopefully some of them for good reasons, but also quite a few for bad reasons. Right? We've seen one of the other cryptocurrency players in our space in the last couple of years. They had an insider malicious threat from one of their employees who over the course of about 6 months was modifying the balances of users in their database. And this one or maybe 2 individuals were able to get off with just over $600 million. Right? This was a pretty successful heist in the scheme of heists. Okay, and we've started to see some even more nefarious activity happening where we now see people sending emails like this out that are perfectly worded English. This is no longer an easy-to-spot phishing attempt, but people sending invitations, sharing actual valuable goods to entice someone to start a relationship. We saw this event over the last year. We saw about a 7-month spearfishing campaign, which started with an email very similar to what I just showed, where one of the insiders at the company was lured into building a relationship with one of these malicious outsiders who looked and had a public presence like a normal person. After a 7-month spearfishing campaign, he was able to infiltrate their network. About 57 days later, I believe, after fully traversing, mapping, understanding their network, was able to make off with about $5 million. And so where we're starting to see our industry evolve to is we're no longer seeing these one-off vulnerabilities from XSS or cores or timing attacks or kind of the last generation of attacks, which we still need to be aware of. But we're now seeing these highly targeted phishing attacks that are tailored to individual interests. Right? Think about something that you really like, something you published online. This is something that might be taken advantage of or exploited. Right? And so where we see these exploitations happening, it starts to paint a pretty tough picture for tech, where tech's really getting pwned. Some of these offers at the bottom are a hard thing to refuse, even for a seasoned technologist or someone that knows what to look for. And when we look at what's getting pwned, these are things like root cloud tokens, where that one person on your team has root access to all of your environments. Or maybe the root database credentials to production, where that one person can get inside and modify the fields in your database. Or maybe something like production network access, not direct access to one specific piece, but now you're inside, you can map the network and find those other vulnerabilities. Or any other number of things that have those single point failures that can be abused inside. Okay? And to drill in on this problem, our collective goal in technology is to digitally provide value. And one of the reasons that we think a lot about these kinds of threats and how to secure the future of our company is that Bitcoin is pure digital value. It's the low-hanging fruit here, right? We think more and more value is going online, but Bitcoin is currently the purest and simplest form of that. So we think we are a leader, or our space is a leading indicator in civilian security. So if we're seeing it, you might not see it yet, but you will in the near term. And what really terrifies me about this is that living in a space where we have these single administrators or these single database owners or these single credentials that we're building large companies and technical innovators that the rest of our lives are being stored inside of, this is something that provides a single point failure that can cause us to all come crumbling down. And so this is a core problem I think we really have to address. With these kinds of threats out there, how do we actually protect ourselves? And there are a couple options that we see a lot of people deploying today. One is traditional organizational sharding. Okay? So this is the left hand watching the right hand, so that as you progress through your evolving and growing company, you've always got somebody watching what else is happening, and you don't have that single person that can really do that much inside. And when we think about scaling over time, you might start with that one engineer, the founding engineer that builds the company around himself. Maybe at some point you split between a development organization and an ops organization. And we're not going to talk about the philosophy behind this, but bear with me for the analogy. Ops may then split between you got your cloud org and your database org, and you start to split engineering as well. So as this progresses over time, if you're a mobile engineer that wants to work on deployment and modify the images and maybe get some new databases provisioned, this becomes a really slow process. And the other unintended consequence of this is the capability that you have at an organization over time becomes a summation of all the privileges someone has given you from the time you were hired to the time you leave. And this is not how we want to grant access. We don't want the people that have been on our teams for a long time to just have access to everything. We want them to have least privilege and really treat security properly. And we think when we do this, innovation shouldn't just be a couple guys sitting around the table that are freely sharing access to everything else, but this should be an organization that can continue to innovate from the inside out, right? So we want to see our team innovating with a small, empowered group like this, not at an enterprise where this is an actual screenshot of my calendar in my last job in the government. This was not the kind of efficient innovation that we want to see in the future of a lot of our organizations. Okay, so the next approach that people have taken, and there's been a lot of money poured into this recently, is in intelligence. We think of this as iteration number 2. There's a lot of great work happening in behavioral modeling and clustered and supervised and unsupervised machine learning. And we all know data science is hot to optimize and really find those anomalies on our network. But what this still misses at the core of it is, regardless of what you think about this individual, what I think is the real failure of what happened here was there was one person, and despite all of this intelligence, there was still one person at the core of it that could siphon all that data off the wire. Okay? So when we think about the future of our security, we don't want some iterative improvement to just get slightly smarter. We want to really reinvent. We don't want a faster horse. We want a whole new way of traversing and securing without stifling our organization's ability to innovate. And so for some motivation, where we started looking at this problem is how are some real secure things stored, like our nuclear launch codes. So if you've ever seen the president at an appearance or in person, you'll usually see a military officer near him carrying this black satchel, or this is called the atomic football. Okay? Inside of this atomic or nuclear football is where a device sits that can remotely share a message with the rest of our nuclear agencies that can initiate the sequence to launch a nuclear warhead. So we've got the carrier and the nuclear football. And next to this, our president will have separately, in order to use that nuclear football, he carries the gold codes, which have to be input for that device to work. Once he's enabled that device, so the president and this military officer have come together, that'll broadcast a message that the Joint Chiefs will see. The Joint Chiefs will then convene and decide whether or not they want to further propagate that relay. And if that makes it all the way down to one of our nuclear silos or submarines or some other asset, we then still don't have a single person that can perform that action, but instead we abide by the two-man rule. So two individual people that have to individually reason about the order they've been given and if they're supposed to turn that switch. And so what we've taken out of this is that real value is not protected by any one individual. It's also not something that one individual can't kick off that process. Real value is actually protected by consensus, right? And where we live in this world where we see these highly targeted phishing attacks that are tailored to individual interests that we've seen pwn a company time after time after time, we need to use this in such a way where even our administrators don't have full access. We want them to be empowered, but we don't want them to be a single point of failure. That's not safe in today's world. Okay? So the way that we've implemented this is breaking it into 3 key steps, and we call this 3-phase consensus, which is core to a large part of the infrastructure at Coinbase. We believe deeply that anyone should be able to propose any change. If we hire this great innovator that has an amazing idea about how our website, our front page, our core transaction processing should be slightly different, we want them to feel empowered to change that. This is core to having great people at all of our companies. Once that proposal has been made, the step where we want to introduce that consensus is in the approval phase. We want anyone to be able to propose just about any mutating action around our environment, but we want to make sure that consensus is required to actually approve that proposal for application. And once we've achieved that quorum in the middle, we believe anyone from someone on our business teams to someone on PR that wants to time a launch directly with when our press release goes out, anyone should be able to apply because our quorum or consensus has already approved this. And now, before I was in this room, we had a great speaker from Github, and it turns out a lot of us are actually using some of the core technologies that can power this workflow today. And one of the great enablers for that is actually Git, right? Distributed version control, where we have no single point of failure, but we have a lot of little masters that can propose changes to someone else's repository. And so we've taken that a step further, and to the pull request model that GitHub has made easy for us, we've deeply tied this 3-phase consensus model into how we use Git and GitHub inside of our environment. So we believe that anyone should at any time be able to create a pull request, and GitHub has done a marvelous job with making this something universal. Once that pull request has been made, for those of you that are familiar with this, we'll have some comments and we can discuss or explain what this pull request is, why we're creating it, what it's supposed to do. And you can modify all the changes to our source code on the other side of that. But once this proposal has been made, we don't allow any individual to immediately merge this or tie this directly back into our master or development or staging branches inside. So we have this robot inside. This bot for us is called Soren. Soren will see everything that's happening. Soren will comment, and it'll say, hey, this is great. I really appreciate that you, some engineer, maybe it's not even an engineer, but somebody that wants to propose a change. We think it's great that you want to propose a change to the core of our company. But before we're going to allow you to apply that, we're going to need 2 other people to approve that change. And we have varying levels of consensus and quorum that we rely on inside. And before we've achieved that consensus, our internal deployment buttons will be blocked. You will not be able to roll that code out or start the development to staging to production process without having that quorum right off the bat. Okay? And so after that robot has commented on side, we'll require multiple individual people. So we might have, say, Chris comments first, and then Neil comments second. And once we've gotten the +1 or maybe a -1, or somebody says, hey, wait a minute, this will cause other problems, we don't want to roll this out. Once that quorum has been achieved, Soren will say, hey, this is great. We don't just have one person here. Multiple individual people have approved this. Now this is OK to start the rollout process to our production environments. And so once this has happened, Soren will unlock the next stage, where we can begin rolling that out. And this is really important that we've democratized this. So there's no bureaucratic process. This is not pushing up to your manager. This is relying on the individual experts that we're building our company around. Okay? So Soren will then approve that. We can then merge that into master. And what's happened there is we've achieved that two-phase consensus inside, right? So multiple people have told us this is OK. And now we can proceed to hit those deploy buttons and proceed to the next phase of our environment inside. Some of the tenets that we've learned are really important for rolling this out and using this inside is, one, this has to be democratic. This is not intended to be another code review process. This is not enforcing some practices or standards, which are really we see as a separate problem. This is an elegant thing we can build into this process, but it's really a separate problem. This is a democratic way of allowing multiple pockets or individuals in your company to roll things out into production, right? So really important that this is democratic, not rolling up to your manager or the person you report to. Okay? This is then a fully distributed process. So while we're having multiple edge nodes or multiple individuals approve this, we don't want to have that one single point failure. So even in this case, GitHub is not a single point failure. We have other protections around this. And the last unintended consequence that's worked really well with this is by requiring this consensus inside. When some empowered engineer wants to roll something out to production, they know they're not going to go through some policy or document or procedure. They have this automated and streamlined way of getting one of their peers engaged in that process of putting it out with them. And what this has done is, I think, given us a more cohesive and collaborative engineering team where everyone knows they have to work with some peer, right? And so this has helped bring us together. One of the more academic and stronger cryptographic ways that we've also implemented things like this inside Coinbase is with Shamir's secret sharing, or for those of you familiar with the idea, M of N secret sharding, so that you may have N people that hold the keys to unlock something, and you don't need all N of them to unlock this. So if you have 7 Ns, in some cases, any 5 of those 7 can come in to perform some action. One of the elegant ways that you can all use this in a publicly available tool today is with the Vault project from HashiCorp. HashiCorp are the guys behind Vagrant and now Otto and Packer and Terraform and a lot of other good tools that are a core part of a lot of our infrastructures. Okay? And the implementation that they have, if we're going to create a 2 of 3 M of N Shamir secret sharing way of accessing some of our secrets, when we initialize their vault, we'll tell it how many shares we want, that's the N, and what the threshold should be for unlocking some secret actions, that's the M. In this case, we're using a 3 of 2. So when we create this, it'll create those three key shares, and any 2 of them can come together to unlock the vault. So in this case, when we first look at this, it'll tell us that the vault is sealed, so no one can get the secrets inside of it. Once the first person, any one of those 3, submit a part of their secret, that'll take the first step towards unsealing the vault. When we have a second person, either the second or third person in this case, submit their shard, that will unlock it so we can proceed with sharing some of our secrets. And this is at the core of how we store a lot of our pieces of crypto and private keys inside of Coinbase. And we blogged extensively about this. We're pretty public about our implementation. We also make this available for our users inside so that you as an individual can have your own multi-shard way of storing your keys. So when your laptop or my laptop or someone else's is compromised, your core secrets or your value is still secure. Right? So one of the things that has been important about managing in this is that at the beginning stages of a company, we often have this hero culture. It's something we try to scale our ways out of, but hero culture is really important at the beginning for getting a company off the ground to begin with at all. This type of consensus infrastructure I don't think is appropriate for a really small startup or just a couple guys that need to be working really quickly. But as we scale over time, this is something that by relying on multiple people and keeping our team democratic and fully enabled has allowed us to still have really empowered developers inside, but in a calculated manner move away from hero culture so that we can all continue to move effectively. And our ultimate goal here is we want to be in an environment where we can still and continue to have really small subsets of people inside of our company that can continue to innovate and create the next great product for us in cryptocurrency or for you in your company, so you can keep moving forward, have empowered engineers, and ultimately have a great time with the best engineers inside of your organization. So to wrap this up, the model that we believe is core to the future of our infrastructure and we think is a valuable future piece that we'd like to see in a lot of our partners' infrastructures and our colleagues as well, is this three-phase consensus where anyone should be able to propose any change. You should require consensus on the ability to unlock that. And once that's achieved, anyone should be able to apply that inside. So what we've done here is really learning from the past, embracing that we see these individuals getting compromised, securing not by some smarter algorithm or behaviorally modeling what people are and are not doing or relying too heavily on machine learning inside, but really designing this threat out at the core of it. And finally, using this as an innovation engine inside of your organization. So that's what we're up to at Coinbase. I'm very happy to talk about or share more of what we've done inside today. Thank you.
So it looks like we have a few minutes for questions. Did you want to take questions now, or maybe outside, or?
Yeah. Why don't we take? How about we take 2 questions now, and then we'll let you get out for lunch.
So if anyone would like to come up to the microphone and ask a question, more than welcome to come up. While people are coming up, I love this consensus-based model. By the way, it lets you keep innovating, keep moving, but it keeps you like really secure in the process. Looks like we have a question here.
Thank you, Jacob.
Yeah, thank you very much for the talk. It's really great. I'm curious, I mean, if these hackers can target people over 7-month periods, really complex things, why can't they just, eventually target 2 people or 3 people or 4 people within an organization and eventually reach consensus?
Yeah, that's a great idea. If our whole entire company is owned, if every engineer is compromised, there's really not much we can do at that phase. So what we do instead, and this is just a practical piece for all of us, is this is only one small piece. So using that intelligence inside, having a lot of tripwires, honeypots, alarms, actually modeling some of our actions inside, that's a really core additional piece in this that puts us focused on the race where if and when someone is compromised, we want to detect that before they can laterally move to other endpoints inside of our environment. So this is just one small piece.
Do you have any overrides so that if consensus was achieved by the wrong people?
That's an awesome question. One of my favorite breaches that I've seen in the last 12 months was through one of those overrides, so no, we do not. We've seen those abused too many times. What instead we have is a really cohesive team with round-the-clock schedules and escalation policies that ensures that there's always at least 2 people for really core actions. We also have different levels of consensus inside where if you're doing something really core, like you want the ability to delete the whole Amazon account, we want to make sure that the level of M required to perform an action like that is really high. But for something smaller, like changing the CSS on our website, that's a variable threshold that we get to control.